Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019, Part C, question number 3. The question is, the outermost cell of an atom of an element is 3d3. We need to find out the spectral symbol for the ground state. 4 options are given and we need to choose the correct option. So let's get started. So this question comes from the section Atomic and Molecular Physics, and the concept involved here is atomic term symbol. So when we talk about the electronic configuration of an atom, it tells you a partial description of the arrangement of electron in different energy levels within the atom. It does not give you the complete picture. Like electronic configuration tells you about the arrangement of electrons in different energy level depending on the principal quantum number n, and in different orbitals with different orientation depending on the value of the angular momentum quantum number L and corresponding magnetic quantum number ml. But this configuration does not comment anything about the spin orientation of the electrons. Arrangement of electron in the atom is also affected by the interaction among the orbitals and the spin. So when we talk about the energy level of an atom, not only the electronic configuration but also the types, the different types of electronic interaction like orbit-orbit, spin-spin or orbit-spin interaction has to be taken into consideration. In such cases, energy levels are called terms and represented as term symbols. So the general representation of any atomic term symbol is represented as 2s plus 1 Lj. So here S is the resultant spin angular momentum quantum number, 2s plus 1 is the spin multiplicity, L is the resultant orbital angular momentum quantum number, and in term symbol it actually represents the atomic states such as S, P, D, F depending on its value. And J is the total angular momentum quantum number. So this representation is as per the Russell-Chandler or LS coupling scheme. Now here we need to find out, we are given a the electronic configuration of a element, and we need to find out the ground state, the atomic term symbol for the ground state. So how to find out the term symbol from an electronic configuration? So we have to follow certain steps. First of all, consider the outermost cell of the electronic configuration. Now here in this question it is given as 3d3. Now second step would be calculate the value of L, capital S and capital J. So we are given the orbital here is 3d3. So here we have it is d orbital. So for d orbital, the azimuthal quantum number L will be equal to 2 and the corresponding magnetic quantum number ml will be -2, -1, 0, 1 and 2. So it will have 5 subshell. Now we have 3 electrons. Now according to the Hund's rule, pairing of electron will be done after each subshell has got 1 electron. So we have 3 electrons and they will be filled in the subshell one by one. So they'll be filled up like this and 2 subshell will remain empty. And here if you calculate the total orbital angular momentum quantum number capital L will be equal to summation over ml, which is equal to modulus of -2, -1 plus 0, which is equal to 3. So capital L equal to 3 means this signifies capital F state. Okay. Now let's talk about the spin part. So here we have 3 unpaired electrons. So each will be having spin half. So total spin angular momentum quantum number capital S will be equal to 3 by 2. So from that we can find out the spin multiplicity 2s plus 1 is equal to 4. So after we have got the value of capital L and capital S, next is calculation of total angular momentum quantum number capital J, which takes the value from modulus of L plus S to modulus of L minus S. So if we put the value, it will take the value from the modulus of 3 plus 3 by 2 to modulus of 3 minus 3 by 2. That means it can take the value from modulus of 9 by 2 to modulus of 3 by 2. So the values will be 9 by 2, 7 by 2, 5 by 2 and 3 by 2. So we have got the values of 2s plus 1, L and J. So by using the general expression of the spectral term, we have got four spectral terms, that is 4f 9 by 2, 4f 7 by 2, 4f 5 by 2 and 4f 3 by 2. Now the question is, we need to find out the spectral symbol for the ground state. So now how to decide out of the four symbols which of them is the spectral term for the ground state? So here we have to follow certain rules to determine the ground state of the spectral term. So now we know that the ground state is the most stable state according to the Hund's rule. So here the spectral term with highest spin multiplicity is the most stable. So that means the spectral term with highest multiplicity will give you the ground state. Now if you look at the four spectral terms, each of them has the same spin multiplicity, that is 4. So from this rule we cannot comment on which of them belongs to the ground state. So second rule is, if the spin multiplicity is same, then the value of the capital L will decide the ground state. So here the value of L, now in this case, the lower the value of capital L, lower will be the energy state. Now in the given case, all the spectral terms have the same capital L value. That means they are in, all of them are in capital F state. So that means this rule also does not help. So now rule number 3, if both spin multiplicity and the value of L are same, the deciding factor would be capital J. So here there are actually two rules. The first rule is, if the subshell has more than half filled electrons, then the term symbol with maximum J value will have the lowest energy. And second rule is, if the subshell has less than half filled electron, the term with minimum capital J value will have the lowest energy. Now in our case, we have D subshell as it is already given, and D subshell can contain, it has 5 subshell and each can contain 2 pair of electrons. That means total D subshell can, D orbital can contain 10 electrons. But we have only 3 electrons in the outermost shell, which is less than half filled. So less than half filled means we have to follow the second rule, that is 3b. So second rule is, the term with minimum J value will have the lowest energy. So out of the 4 terms, the minimum J value is 3 by 2. So here the ground state spectral term will be 4f 3 by 2. Now let's check the option. Now if you look at the option, you can see that option A is matching with our result. So the correct answer for this question is option A.